Kia ora. Well, thanks for having me on the show, Adam. So I'm a structural engineer and I work for a consulting company called Holmes, and I'm based in Christchurch, New Zealand. I've been a structural engineer for around 17 years, and during that time I've worked on all sorts of buildings. But from early in my career, I was really interested in timber and was fortunate enough to get to work on my first timber project quite early on, which was a display hall for aircraft at a transport museum in Auckland. Now, that project was a great experience. We had a really collaborative design team from the architects through to the suppliers, and even back, and this was back in about 2009, a life cycle assessment was done comparing the as-built timber structure with an equivalent steel design that we did. So showing just how much better the timber performed from a sustainability perspective. So that was at the beginning of my career up in Auckland. My move to Christchurch, which is where I'm now based, was prompted by the Canterbury earthquakes. So I have a long list of assessment and strengthening projects on my CV. But I've also worked for a couple of years over in the Netherlands and was able to work on a few timber concepts over there. Fast forward to today, and a big part of my role with Holmes is championing both timber and sustainability. I'm also the Vice President of the New Zealand Timber Design Society, and recently was part of a governance group for the establishment of the New Zealand Timber Design Centre, which is a new facility still being established over here in New Zealand that will be the equivalent of WoodSolutions in Australia and provide similar services but for the New Zealand market. So that's really exciting. And also in the timber space, I have been involved in the development of some design guidance, which is how the topic of today's webinar has come about. So with another colleague of mine, Ben White, we co-authored a high-level design guide on post and beam construction for the New Zealand context.
Yeah, fantastic. And you're probably going to be humble, Lisa, but you got more experience than most, you know, getting onto this stuff really early. So we're lucky to be able to be speaking to you today. And I've got enormous amounts of respect for the New Zealand Timber Design Society. Some of the best technical information in terms of your guides, also your webinars are phenomenal. And we are speaking about the post and beam one you've already co-authored. So can you just tell us a little bit about the reasoning and the drivers behind creating this guide?
Well, I actually think that I've been involved with more timber projects that haven't gone ahead and been built than ones that have. And
totally understand that.
Yeah, unfortunately, I don't think it's uncommon. And there's lots of reasons that these projects don't get off the ground, but often it's because the project teams aren't as familiar designing with timber as with other materials. So they don't have that same gut feel of what's going to work and what you need to think about early in the design process. And so this obviously leads to inefficient structures that sometimes just don't work, or to make them work are really expensive. So we wanted to provide a guide that would give people a bit of a head start. So help architects and engineers develop timber concepts that would set them up to deliver successful timber projects. And post and beam is a really simple system. So a good one to start that allows, there's lots of benefits for a post and beam system, open flexible spaces. So will allow the development of more types of timber buildings to be built out of timber.
Yeah, fantastic. And so the guide has a lot of different information, and you'd think that the highest leverage points is that early optioneering stage, would you say, at the very start? And what's the role of a structural engineer beginning at the start of the process, and how might it be a little bit different to what we're used to?
Well, again, it comes to that, the fact that generally the design teams aren't as familiar with what's possible in timber. So I think it's really important that right from the beginning of the project, the structural engineer is working closely with the architect to ensure that the grid layouts and floor depths are optimised for timber. In the design guide, we include things like span tables and examples of connections that can be used for post and beam construction to help optioneer at these early stages. I often find that people have kind of got it in their heads that the grids might need to be smaller, but they underestimate the overall floor depth still. So yeah, which can cause huge problems later on if you then realise that big services need to go under the beams, or you've got to add even more depth for acoustic and fire treatments. Yeah, so having a deep getting that right from the beginning is a huge help.
Yeah. And I guess from the multidisciplinary point of view, it's like something that comes up on the podcast a bit. It's having enough people in the room at the start. I mean, from your perspective, who needs to be in the room and what sort of considerations are best to go on at the very beginning of the project?
The more of the full design team you can have in at the beginning, the better. So as well as the architect and engineer, it's important to get that early input from the services, acoustic and fire consultants. And although I know clients hate locking in suppliers early, if you can get a supplier on board right from the beginning, there's so much experience and value that they can add, sort of making sure that those designs are optimized and can be built efficiently. So with all these players on board, and if they all have a deep understanding of how timber behaves, then most of the big risks for timber projects can be designed out right from the beginning.
Yep. I guess it's is it easier said than done? Because I mean, how much timber, consultants with timber experience that are out there that you can get on board, and you need the full team, I'd imagine, with that experience to have a success, to make sure that you're not locking in a poor design at the very start. Is that right?
I mean, with the increase in the amount of timber that's being built, there will be lots of people learning as they go. And so I think it's important, if you don't have an experienced team, just to factor that into the design process and make sure that you're spending that time early in the design, not rushing through the concept, making sure that you're spending more time up front and getting the input from all those different players before moving to the next stages.
Yeah. Well, even from an engineering point of view, do you think it's surprising, like say if someone's doing it for their first ever engineering job, is it very easy to undercook the amount of time it really takes to actually do a design? I'd imagine, especially in the New Zealand context with the seismic requirements you have. Is that it?
It is very easy to undercook the design, and there aren't as many cookbook solutions for timber out there yet either. We tend to be doing all the connections and things from first principles, and everyone is a little bit different, which just takes a lot more time than looking up a steel cleat in a table.
Well, hopefully, do you think we might get there one day where with every design, maybe 5 years, and hopefully that'll help drive down the costs and overall simplicity and really get rid of some of those mistakes that we might be used to?
Yeah, well, some of the innovations in this space that I think are really exciting at the moment are not the ones that are making us go bigger, taller, larger, but are the ones that are focused on standardizing these timber systems and, allowing repetition so that we can build normal buildings out of timber efficiently and cost effectively, and which will increase the total volume in our of timber used substantially. So at Holmes, we're really trying to implement these efficiencies in our designs. So look for them and repeat them from project to project. And yeah, part of the Holmes family is a company called WoodSolutions that has a research and testing, as a research and testing facility. And they're also quite heavily involved in the mass timber space and have done quite a lot of work on a suite of connections that we're really excited about in the space of doing exactly that, trying to standardize a timber system. And that those connections have been picked up by Hilti, who are going to bring them to market. So watch this space. Very exciting.
That is super exciting, and it solves a lot of issues with that replication. Now, look, let's back to the beginning of the project. What are some of the other key ticket items at the very start that we need to be getting right, do you think?
Well, I've got a long list, but
that's totally fine.
As well as getting that efficient grid system and realistic floor-to-floor height, I think it's important to consider how you're going to achieve fire and acoustic performance. Because if you try and add those in later in the design, it has all sorts of flow-on impacts to other parts of the design. And another area that I think needs to be considered earlier than you might with other types of construction is the fabrication and erection of the components. So crane time and increased labour obviously has a direct impact on construction costs. So it's really important to be thinking about the number of lifts you're going to do with a crane, and then how long it takes to actually achieve the connections on site. Going back to some of the work that WoodSolutions have done, again, they've done quite a lot of time and motion study on installing different connections types, and it's amazing how much variation there is and how long some connections can take to actually install in the field, and how difficult they are. How hard it is on the people doing the work, and then how hard it is also to do the QA on them, to actually see that the connections have been installed correctly. So taking all of that into account as you're designing.
Yeah, it's huge. And yeah, at the end of the day, it's people implementing these, and it's not just skewed screws at 300 centers. It's like, if you multiply it out, there's a lot of screws that go into this that people have to do at the end of the day, which we might forget sometimes. And diameter or something. I think it was the same conference we went to. It was the New Zealand Woodworks conference, and I remember just one of the presentations talking about never specify screws above a certain diameter. And yeah, for that particular project, it was the biggest mass timber project in the world, and the biggest issue they had was just that the screw diameter not being practical.
Yeah.
What are some of the other major problems and things that designers need to be watching out for in these buildings?
Two of the things that spring to mind are tolerance and weather protection. And I think both of those were also mentioned in depth at the conference you mentioned there. But I think with tolerance, although CNC machining can mean that the timber elements themselves are fabricated very accurately, we still need to remember that there still needs to be design tolerance for constructability. And often, these timber elements are being erected on a concrete substructure or concrete foundation. So it's not just the timber elements that we need to consider, it's what they're being connected to. And the fact that timber's a natural material, so it shrinks and swells. So we need to design for the tolerance for that, taking that into account as well, especially during construction. I've heard about, instances where local swelling at the end of a column has meant that you can't get the beam to fit between the two columns, or even instances where swelling has fractured screws that are installed perpendicular to the grain. And you just don't have to think about this when you're designing with steel or concrete. So it's an added layer of complexity for timber designs, but it's not insurmountable. We've got solutions for, practical solutions that does mean you can still design in timber in a cost-effective manner. So I think I also mentioned weather protection, and of course that's to help manage the moisture in a structure. So it's important that just all projects, when they get to site, or even the elements on their way to sites, have a moisture management plan to limit the impact of that moisture movement. And there's two basic components to that. One, avoiding prolonged exposure of the timber to water, having controls in place for that. And then before the timber is enclosed in the structure, making sure it's got time to dry. So yeah, sounds simple, but in reality can be a challenge to manage.
Yeah, I like it. There's a lot in that. Well, yeah, there's been a lot of wisdom we've been lucky to hear. What are some of the latest innovations that you're seeing in this space that gets you excited?
I mentioned the connections, the suite of connections that the Home Solution teams are working on, but in that same sort of field of innovation that will bring timber to the masses, if you like, all the different suppliers and fabricators who are working on like different prefabrication components, and bringing them together. And that's why I really think organisations like the Timber Design Centre and WoodSolutions, you wouldn't necessarily call them an innovation, but they foster innovation. They foster collaboration, which is going to really increase the uptake in timber.
Yep. Well, it's an exciting future. You've mentioned a few things. Is there anything else that you'd like to plug, or any places you'd like listeners to go go and learn more what we've been speaking about today?
Well, I guess our team at Holmes are really passionate about timber projects and always keen to hear about new opportunities. So we are based here in New Zealand. This is where Holmes started, but our fire team have got quite a good presence in Australia and work on quite a lot of big timber projects over there. We're also present in the US and the Netherlands. So we've got a broad experience base to draw on, and yeah, always keen to hear about new timber project opportunities. And I just want to mention the New Zealand Timber Design Centre again. It's more of a watch this space because it's still in the establishment phase at the moment, but I think that will be another great resource for those, not just those who are starting out on their timber journey, but a collaborative space for those who have, a part of the team already.
Yep. Well, that's great. Well, thanks so much for coming on the podcast, Lisa. It's been a great learning session with yourself today. Appreciate it.